So this video is intended to just explain how to get from phosphoric acid, which is what I have written here, and deprotonate that all the way down to an isolated phosphate ion. So to do that, we're just going to demonstrate as many times as we need to, which would be 3 times because there's only 3 hydrogen protons to be split from this the acid. So first off, we do it once here, giving us dihydrogen phosphate. Now, this was neutral because phosphate has a -3 charge, and the 3-hydrogen has a +3 charge, and so this whole thing here is actually neutral. Once we lose the proton, it becomes overall negative, just like that. Now, you might ask, why does this proton leave the compound, the acid? Well, you can actually see here that it would just become water if we were to add it to hydroxide, which, of course, the positive hydrogen proton would go right to this negative hydroxide, and that would become the neutral base for water. So then we would just do this once again, repeat the action, take our dihydrogen phosphate, we lose yet another proton, we get 2 hydrogen phosphate, which is overall, why did that give me a triangle? Overall -2, or 2 minus, sorry. Either way. And again, you'd have some water in excess. One more time, because of course we only have one last hydrogen to go through. So we take our hydrogen phosphate, we deprotonate once more, and we are left with our polyatomic anion phosphate, which is -3. And a bunch of water. So that's how you get to an isolated phosphate ion, and you might wonder, well, what does the structure of this anion look like? Well, it's basically just a phosphate. It's a bit long of a bond. It's a phosphate with an oxygen, another oxygen. Oh, that's quite horrid. And yet another. Now this just denotes the 3D structure. We haven't gotten into this yet, but something I picked up along the way. So you also have a double bonded oxygen up here. Now there are different variations of this structure, but it's simply how I'm going to write it now. These 3 oxygen, which used to be hydroxyl groups in the phosphoric acid, with their hydrogens attached to these, previously had a bond to hydrogen here, just like that. But we've deprotonated all of these hydrogens, so you can kiss all those goodbye, and now they all have negative charge. Oh, excuse me. Yes, they all have negative charge now, except for this one, which has kept its charge thanks to its double bond. Yes, that's your phosphate ion. One other thing I should mention, that I completely forgot to, is we have phosphoric acid, right? So we're deprotonating phosphoric acid, and as Dr. Fortney has told us time and again, phosphoric acids will give us 8 bases. And wouldn't you know, the phosphate anion is an 8 base. Perhaps I should specify just a little bit more here at the end of the video. I'm not too good at editing, so I had to throw this in at the end. But when we're writing the charge of these molecules, you have individual charges of the cation and the anion. So the individual hydrogens have their own charges of +1. Each hydrogen has +1, so we're dealing with protons and losing their electrons to the bonds of the anion. So you have 3 minus and 3 plus, so overall it's neutral. And then over here you have 2 plus because we've lost one of those protons. So now our plus charge is a little bit weaker. And so we still have the 3 minus because we haven't lost any of the phosphate. Clearly we haven't. We have the full-on structure over here. So then once more down here it's still 2 plus, 3 minus, have plus, there's only 1, you don't really need to specify a number. You have 3 minus, plus, 3 minus, and then finally we all know that the phosphate ion, anion more specifically, has a 3 minus charge, as I've been writing through the whole of this process of the deprotonation of the phosphoric acid.